Dear students, welcome to today's lecture. In the last 3 lectures, we discussed digital to analog converters and the specification of DACs and its classification. In this lecture, we are going to discussing about analog to digital converters and the specification of ADCs and its different classifications. Let us see the details. What is analog to digital converters? That is analog to digital converters that does the inverse function of DAC. That is, it convert analog signals into equivalent n-bit binary digital signals. Okay, and the general block diagram of an ADC is shown below. Here, the input signal, that is an analog signal, that is a voltage signal, and first block is pre-filter or anti-aliasing filter, and the second one is sample and hold amplifier, third one is quantizer, fourth one is an digital processor encoder. Okay, so then what is the function of pre-filter or anti-aliasing filter? This pre-filter or anti-aliasing filter avoid the aliasing effects. That is, it rejects the incoming high frequency signals and band limit the incoming signals to a particular frequency FM. And what is the function of sample and hold circuit? The sample and hold circuit samples the incoming signals at a different sampling rate, and the sampling rate Fs is equal to 2 FM. Okay, and it also holds the sample value for a certain period of time. Then quantizer that quantize the sampled signal. That means the quantizer segments the reference voltage signals into sub-ranges. Typically, for an n-bit digital output, there are 2:a sub-ranges, and the quantizer quantize the sampled signal. Okay, and the encoder, digital processor that forms the encoder circuit which encode the sub-ranges into equivalent digital output code. Okay, this is the basic block diagram of analog to digital converters. Then we shall see the analog to digital converter specifications. First is resolution. Then resolution is, that is weight of an LSB, that is already discussed in digital to analog converters, 1/2n into some voltages. So the resolution, that means that is the smallest change, that is the minimum change in the signal which is accepted for the conversion, and it is decided with respect to the number of bits, and it is defined as the resolution is equal to 1/2n. Resolution is equal to 1/2n, where n is the number of digital output word bit. One equation, that is VFS by resolution. VFS by 2n, 1/2n is the resolution. VFS is the full scale input voltage. This range, that is VFS by 2n, that the ratio of VFS by 2n gives the minimum change of input voltage, the delta VI, minimum change of input voltage, which can cause the change of 1 LSB at the output. Which can cause a change of 1 LSB at the output. This is resolution. Next is quantization error. In analog to digital converters, after the sample and hold circuit, there is a block, that is quantizer. That quantizer quantize the or rounded off to a particular level. Suppose if there are a number of bits, there are n quantization levels, and while doing so, some errors occurs in the actual value of samples. That is, this error is called quantization error. And if the higher the value of n, that is quantization levels, lower will be the quantization error. Next is analog error. Analog error in an analog to digital conversion is due to the variation in the switching point of the comparators used. The variation in the switching are mainly due to the offset error, gain and linearity errors of the amplifiers. Next is differential nonlinearity error. Differential nonlinearity error is the difference between actual steps width with the ideal step width. Ideally, the step width is 1 LSB and the deviation from 1 LSB, step width is or step size is 1 LSB and the deviation from 1 LSB, that is called the differential nonlinearity. Then integral nonlinearity, that is the variation in the transfer characteristics of an ADC from the ideal value. Then conversion time is the time required for the analog to digital converters to convert the analog input value into its equivalent digital data. Then input voltage range is a range of voltage that an analog to digital converters can accept as its input without causing the overflow in the digital output. Next, classification of analog to digital converters. The type 1 classification include programmed analog to digital converters and non-programmed analog to digital converters. In programmed analog to digital converters, the conversion is made in fixed number of steps with equal time intervals. Non-programmed analog to digital converters require a sequence of process and the time interval depends on the response of time. And the another classification type 2 is closed loop and open loop analog to digital converters. In closed loop analog to digital converters, the analog voltage obtained initially is fed back to the input side and this voltage is compared with the analog voltage under conversion. And in open loop converters, direct comparison is between analog input voltage and set of reference voltage. There is no feedback. And the type 3 classification include the capacitor charging type analog to digital converters and discrete voltage comparison type analog to digital converters. The capacitor charging type ADC operate on the principles of charging the capacitor at a proportional rate to the input voltage. And the discrete voltage comparison type ADC that employs the principles of generation of discrete voltages whose levels are equivalent to digital words. And the type 4 includes direct type and indirect integrating type analog to digital converters. The direct type analog to digital converters compare the given analog signals with internally generated analog signals. An integrating type, thus an integration process during the conversion process, thus this conversion process is an indirect one. Okay, this is all about the specification and the classification of analog to digital converters. Okay, thank you.